Hello friends, in this video we are going to see how to tackle the type 2 questions. So let's consider this question. Alek and Alia can together do a piece of work in 5 days, which Alia and Aman together can do in 15 days. After Alek has been working at it for 4 days and Alia for 5 days, Aman then takes up and completed the work alone in 4 days. In how many days can Alia do the work alone? So here we can just also assign the variables for their work per days. So we can say Alek does X works per day, then Alia does Y works per day, and then Aman, he does Z works per day. So now Alek and Alia together complete the work in 5 days. So Alek, if every day he does X works, in 5 days he is going to do 5 times of X works. So this is the work done by Alek in that period. And Alia will do in 5 days 5 times of Y works. And together they complete the work. That means this is the total work. This is the total work in the context of the first statement. In the context of the second statement, Alia and Aman can together do in 15 days. So in the 15 days, Alia will do 15 Y works because every day she does Y works. So in 15 days, she will do 15 Y works. And Aman is going to do 15 Z work in the same period, and that is also the total work. And according to the last statement, Alek first works for 4 days. So in his 4 days, he will do 4 X works because every day he does X works. Similarly, Alia then works for 5 days. So she will do 5 Y works in those 5 days. And then Aman works for 3 days to complete the work. Aman works for 4 days to complete the work. So in his 4 days, he will do 4 Z works, and that also is a total work. So this also total work, this also is a total work, and this also is a total work. We can equate this, but we try to maintain that we want to calculate the Alia's days. So we want to get the total work in terms of Y only. So what we can do is, first of all, we can equate the first and third. That gets us 5x plus 5y is equal to 4x plus 5y plus 4z. 5y can get cancelled. That gets us x is equal to 4z. And now we can equate the first and second. That gets us 5x plus 5y is equal to 15y plus 15z. That means 10y will be equal to 5x minus 15z. Just put x is equal to 4z here. So that will make it 20z minus 15z. That is equal to 5z. So 10y is equal to 5z. And now just convert this 15z in terms of y. So if 5z is equal to 10y, 15z, that is 3 times, is going to be 30y. So you can say this is equivalent to 30y. That means the total work is equivalent to 45y. 15y plus 30y, that is 45y. So if total work is 45y and Alia every day does y works per day, so that means she is going to take 45 days, because we know days is equal to the work to be done divided by the everyday work, and hence the answer is going to be 45 days. Easy. Let's see one more. A can complete a project in 20 days and B can complete the same project in 30 days. If A and B start working on the project together and A quits 10 days before the project is completed, in how many days will the project be completed? So this is the typical question that we can solve easily with the help of LCM method or common multiple method. All we have to do is consider the total work as the common multiple of A's days and B's days. So what is the common multiple of 20 and 30? We can say 60. So we say total work is 60 works. Now A does 60 works in 20 days. That means every day he does 3 works. So A's efficiency is 3 works per day. B does 60 works in 30 days. So his efficiency is going to be 2 works per day. And together they are going to do 3 plus 2, that is 5 works per day. Now in what fashion they are working? This is like the timeline. First few days A and B both are working. Then before the end of the job, 10 days before, A leaves the job. So for last 10 days only B was working, because A left 10 days before the job is finished. That means this duration is 10 days. In these 10 days, only B is working and B does 2 works per day. So he has done 2 times of 10, that is 20 works in that period. So out of 60 total works, 20 works are done in this period. That means the remaining 40 works are done in this period. And at what rate? At 5 works per day. So days required is the work to be done divided by the rate at which it is being done. So the days required will be 8 days. That means this duration is equal to 8 days. They are asking the project was completed in how many days? So the total days required will be this duration of 8 days plus this 10 days. Total project was completed in 18 days. So the answer here is 18. Let's see next one. A is 40% less efficient than B. Now whenever you see the word efficient, please understand the question is easy. You just have to write the efficiency form. Now A is already given 40% less efficient than B. So this part is easy because it is already given in terms of efficiency. But the next part is B who can do the same work in 20% less time than C. So first we have to form the relation between time and efficiency. See friends, if a person is taking more time to do a work, that means his efficiency is less. So there is an inverse proportion between time and efficiency. What do you mean by inverse proportion? Inverse proportion means time of the first person upon time taken by the second person should be equal to efficiency of the second person upon efficiency of the first person. This type of relation we call as the inverse proportion. What I am trying to say here is, say the statement is A takes double the time of B to do a work. So time-wise ratio between A and B is going to be, okay, to avoid the confusion, let's use the another words like X and Y. So let's say X takes twice the time of Y. So time-wise ratio between X and Y is going to be 2 upon 1 because X takes double the time of Y. So time-wise ratio of X and Y is going to be 2 upon 1. But then efficiency-wise ratio is going to be, because Y does the work in half the time of X, that means his efficiency is double. So efficiency-wise ratio between X and Y is going to be 1 upon 2. Y's efficiency will be double than X's efficiency. That means if X does 1 works per day, Y does 2 works per day. So this is how the inverse relation works. So if the time-wise ratio between X and Y was 2:1, then efficiency-wise ratio is going to be 1 upon 2. So same thing we have to consider here between B and C. So if time-wise ratio between B and C, we can form, because B does the work in 20% less time. So if C is taking 100 time, B will be taking 20% less, that is 80. So time-wise ratio between B and C is 80 upon 100 or 4 upon 5. That means efficiency wise ratio is going to be inverse of this. That means 5 upon 4. So you can directly now say that if C does 4 works per day, B will be doing 5 works per day. And A being 20% less efficient, 40% less efficient than B, 40% less than 5 is 3 works per day. So A will be doing 3 works per day. Now they say A and B together can complete 80% of the work in 12 days. So A and B together first of all do 3 plus 5, 8 works per day. And such a way they work for 12 days. That means they did 96 works, which was 80% of total work. So total works, if we say total work is TW, it's 80% if 96. So you can first figure out what is total work. The total work is going to be 120. And it's 60% we have to do now. 60% of the work we have to do. So 60% of 120 is 72. So now 72 works need to be done by B and C. So B does 5 works, C does 4 works per day. So every day 9 works per day is being happening, and we have to finish 72 works. So we know days required is the work to be done divided by the rate at which it is being done. So the 8 days will be required to finish the 60% of the work, and answer is going to be 8. I hope you got this method. Let's see one more. Time taken to complete a work by A alone is 100% more than the time taken by both A and B to complete the work. So friends, if you read the statement, first of all you have to realize the efficiency of A and B are going to be equal if A is taking 100% more time. So you have to realize that, and you have to start your question upfront there. But if you don't realize why it's so, let's solve it first. Let's say A takes A days to complete a work, B takes B days to complete a work. So together A and B, they are going to take AB upon A plus B days to do the work. This is what we saw in our previous video, that if A does a work in A days, B does a work in B days, together A and B, they take AB upon A plus B days. Now they are saying the days of A are 100% more than the days taken by both together. 100% more means it is going to be 2 times of this. 100% more means 2 times. So 2 times of AB upon A plus B is going to be A. So AA gets cancelled. 2B is equal to A plus B. That gets us A is equal to B. That means the days taken by A and B are equal. That means their efficiency is equal. So this part you should arrive directly without even going for this all. We can directly start our question starting C does 1 work per day. You can consider this. C does 1 work per day. Now B being thrice the efficient as C, B will be doing thrice the work. So B will be doing 3 works per day. And A and B being equally efficient, A will be also doing 3 works per day. Now B and C together take 12 days to complete the work. So together B and C, they are doing 4 works per day, and if such a way they can complete the work in 12 days, that means the total work is 48 works. This is our total work. Now this work has to be done by A alone now. So if A alone does 3 works per day, to complete 48 works, the days required are the work to be done divided by the rate at which it is being done. So 16 days will be required. So the answer here is going to be 16 days. Now this is a pipes and cistern question. Before we go for this question, let us see how pipes and cistern is related with type 2 questions. Consider this example, friends. There is a tank and there are two pipes. They are filling the tank. Let's say the pipe A, it takes 4 hours to fill this tank, and there is another pipe B which takes 12 hours to fill the same tank if working alone. So now the question is, if both start operating together, how much time will be taken by A and B both? So now you can see it is exactly the same question that we have been seeing, that A does a work in 4 days, B does a work in 12 days. Together they will do the work in how many days? So it is exactly the same. There we consider the total work. Here we consider the total volume of the tank as the common multiple of the times of A and B. So what is the common multiple of 4 and 12? It is definitely 12. So we can say the total volume is 12 liters. Now 12 liters is to be filled by A in 4 hours. So if A alone fills 12 liters in 4 hours, the rate of A is going to be 3 liters per hour. And B fills 12 liters in 12 hours. So its rate is going to be 1 liter per hour. A is also filling, B is also filling. So together they are filling 4 liters per hour. And we have to fill 12 liters at the rate of 4 liters per hour. So the hours required will be 3 hours. So together they are going to fill the tank in 3 hours. So if it is exactly the same, why do we require this different kind of question? Because of one more part we can add here is the negative work. Negative work means what? Consider in the same tank there is a hole, let's call it C, which can empty the fully filled tank, say in 6 hours. C can empty the tank in 6 hours. And now if all three acted together, so A plus B plus C, if all three are acted together, then in how many hours the tank will get filled? So first question can arise in the mind is, how will the tank be filled if there is a hole? Of course it will fill. If the amount of water you are taking out is less than the amount of water you are filling, definitely there will be a moment when the tank will get filled, and afterwards, if you still continue the thing, it will overflow. So we have to find out the time in which it exactly fills. So in this question, you have to again consider the total volume as the common multiple of A's time, B's time and C's time. So what is the common multiple of 4, 6 and 12? It is going to be again 12. The common multiple of 4, 6, 12 is going to be 12. So we'll consider the total volume as 12 liters again. A's rate we already know, it fills 12 liters in 4 hours. The rate is 3 liters per hour. B's rate also we already know, that is 1 liter per hour. A also fills, B also fills. But C empties 12 liters in 6 hours. So its rate is going to be 2 liters per hour, and it is going to empty it. So in 1 hour, A will fill 3, B will fill 1, but C will empty 2. So together they are going to fill 2 liters per hour. And if they now have to fill entire 12 liters at the rate of 2, the time taken is the work to be done divided by the rate at which it is being done, that is 6 hours. So together they will take 6 hours to fill this tank. So this negative work is the only thing which separates the time and work question from pipes and cistern question, but the approach is going to be exactly the same. So let's see that question. Two pipes can fill a tank in 36 hours and 12 hours respectively. If pipe C can empty 1/4 of the tank in 8 hours. So we know if 1/4 of the tank it can empty in 8 hours. So the complete tank it will empty in 8 into 4, that is 32 hours. So A fills the tank in 36 hours, B fills the tank in 12 hours. A also fills, B also fills, but C empties the tank in 32 hours. So we have to consider the total volume as the common multiple of 36, 12 and 32. So 36 is already multiple of 32, it has 4 into it. So we can just say the common multiple is going to be 36 into 8. This is going to be the common multiple, 36 into 8. And that is going to be 288. 288 liters, we can consider the total volume. Now A fills 288 liters in 36 hours. So the rate of A is going to be 288 upon 36, that is 8 liters per hour. B fills 288 in 12 hours, so its rate is going to be 24 liters per hour. And C empties 288 in 32, so its rate is going to be 9 liters per hour. A fills, B also fills, but C empties. So together they do 8 plus 24 minus 9, that is 23 works, or they fill 23 liter per hour. But we have to fill now only half the empty tank. That means we have to fill half of this, that is 144 liter. So we have to fill this much at the rate of this. How much time taken? So time is the work to be done divided by the rate at which it is being done. 144 upon 23. So solve this. It is going to be 23's 5 times. Six times. Just a second. This is going to be 23 times 23 6 times 23 6 times is going to be 138, and then what remains is 6 upon 23. So the answer should be 23 6 complete 6 upon 23. I think there must be a misprint in the answer. The answer should be this. There must be misprint. The answer should be this. Okay, let's see one more. 8% can finish a work in 20 days. After 5 days, they were requested to complete the work in next 8 days. How many more persons should join the group to fulfill the requirement? Now this is type 1 question. We can just solve this as a practice. 8% can finish the work in 20 days. So if I say 1 person does 1 work per day, 8% are doing 8 works per day. And such a way, if they can finish the work in 20 days, that means the total work is 8 into 20, that is 160. After 5 days, they were requested to complete the work in next 8 days. So in 5 days, they did how much work already? So see, total work is 160 work. In 5 days, how much they already done? 5 times of 1, that is, they are doing 1 work per day. Sorry, 5 works per day. There are 8 people. So they are doing 8 works per day, and such 5 days they work for. So they have done 8 into 5, that is 40 works already. 40 works already done. So remaining works are 120 works, because out of 160, 40 works are already done. Now these many works are to be done in 8 days. So every day we have to do 15 works per day. But we have only 8 men who are doing 8 works per day. That means 7 more men should join the group. So how many more persons join the group? Answer should be 7. Of course, you can do it like this, or we can do it with the help of M1 D1 is equal to M2 D2 formula as well. All you have to think is 8 people are doing the work in 20 days. So 8 into 20 is the work they did. But they have already worked for 5 days. That means if this is the work, let's say this is the amount of work that can be completed in 20 days, so out of which 5 days work is already done, 5 days worth of work is already done. Just think about the remaining work that can be completed in 15 days. So this is the work that can be completed by 8 men in 15 days. But we have to now complete in only 8 days. Only the remaining work. So how many men will require? So M1 into D1 is equal to M2 into D2. M1 into D1 is equal to M2 into D2. 8 gets cancelled. So M2 is 15. That means 15 men are required to complete the remaining work. But we have only 8 men already. So how many more should join? 7 more people should join the group. Let's see one more. A man and a woman working together can do the work in 66 days. The ratio of their working efficiencies is 3:2. That means you can say if the man does 3 works per day, the woman does 2 works per day. If together they can complete the work in 66 days, together they are doing 5 works per day, and if such a way they can finish the work in 66 days, that means the total work is 330 works. That is our total work. Now that is to be completed by 6 men and 2 women. So how many days will be required? Every day they are doing, 6 men will do 6 into 3, because every man does 3 works per day, and 2 women will do 2 into 2, because one woman does 2 works per day. So they are doing 18 plus 4, that is 22 works per day. This manpower is doing 22 works per day. We have to do 330 works. So to perform this much work at this rate, what is the time required? Time or days are the work to be done divided by the rate at which it is being done. 330 upon 22 or 30 upon 2, that is 15 days. The time required is going to be 15 days. I hope you got this. Thank you for watching this video. Stay joined for another such